So in this video, we will talk about the different type of chemical bondings, like the covalent bonding, ionic bonding, metallic bonding, and many more. So, like we know that everybody in this universe is requires stability, and to get the stability, they have to do something. Similarly, atom do something. They gain the electron, they share the electron, and they can also attract the electron towards itself because of electronegativity. So, in this lecture today, we are going to talk about the different chemical bonding. So, let's start with the first chemical bonding, that is the ionic bonding. Then we will talk about the covalent bonding, and then we will talk about the metallic, coordinate, and then van der Waals forces of attraction, and not last but not the least, hydrogen bonding. So, guys, we know that everybody is wants stability. So atoms they also want stability. They also want stability like noble gas configuration. So they want to complete their octet, and they want that's why they want. But if you have seen the periodic table in my previous videos, in which the metals are on the left side and non-metals are on the right side of the metalloids, and in between there are some metalloids are there. So metals are electropositive in nature, and non-metals they are electronegative in nature, and they combine. Okay, so metal-metal bond, metal-non-metal bond, non-metal non-metal bond. So these bondings we can find in this lecture, that how metal and metal they just make a bond, non-metal non-metal make a bond, and that bonding, what we will call it, like ionic bond, covalent bond, metallic or coordinate bond, everything. So let's one by one, I'll go to the video and I'll check it. So can you see this picture, beautiful picture we have here? We can see that it's saying it's an ionic bond. Okay, so ionic bond is made between a metal. Atoms donate electrons to the non-metal. So can I say that one is metal, another is non-metal here in ionic bond. In a covalent bond, two non-metals means all are non-metals. They can make a bond. But in metallic bonding, the metals have electrons which are freely moving between the metal atoms. So metal-metal bond is called metallic bond. So I'll start with the conclusion that in a covalent compound, non-metal will combine with the non-metal. In a metallic, metal will combine with the metal. But in a ionic compound, metal will combine with the non-metal compound. So I'll start with the ionic bonding. So ionic bond is, you can see in the crystal lattice, in the salts, where they are heavy high electrostatic bond between them. Okay, so ionic bond we can say when an atom with high electronegativity is En is called electronegativity, which is placed near an atom with low ionization energy. So it may steal the electron. Okay, so one which is having more electronegative, and if somebody is having bigger size or loosely bound electron is here. So this electron will steal the electron towards itself. Why it's having low ionization? Because nuclear charge effect is very far. This electron can easily be ejected. So the atom that gives up the electrons, they become positively charged, and the atom who will attract that will become a negatively charged. So we'll give positive charge means cations, and the atom that gains the electron, they become negatively charged. They are anions. So an ionic bond is something, the electrostatic interaction between the oppositely charged cation and the anion. Okay, so this electron transfer that can occur if the first atom is electronegative, it should be quite high. It shouldn't like that there's a little bit electronegativity difference. They can, attract the electron towards itself. It's not like that. So there will be a partial charge distribution will be there. So, in the second ionization energy of the uh, other electron, this atom, you can check here, should be less. So the metals they can easily lose electron with low ionization energy. Non-metals they have high electron activity. They can easily gain the electron. So because of that, these opportunely charged cations and the anions, they just make a interaction and there will be a complete charge separation will be there, not partial. So we can see, uh, we can say this in ionic bond. First of all, it is an electrostatic interaction. Okay. First point you have to. Second, it is between cation and anion. Second, no, it will be a non-metal and between the metal. And this transfer the electrons, which gives atoms of a filled valence shell, or they both are get stabilized because of their octets getting completed after the by having this bond. So we can say in an ionic bond, electrons are lost or gained, resulting in the formation of ions. Because of that, this bond is between the ions. That's why we call it, it is an ionic bond and it occurs in ionic compounds. Okay, like if I'll take the one example, K, this potassium is from S block element, the first group. Is it? First group, how many valence electron will be there? One only. Okay, one electron. This fluorine is from the halogen family, 17th group. And how many valence electron will be there? Seven. So fluorine want only one electron and potassium required also one electron to complete its octet. So if you will see this, both the electrons they are getting shared. You can check it here. How how the fluorine is electronegative. That's why it's attracting the electron towards itself. You can check it here. Now, if you will see here, this electron is very close to the fluorine atom. Rather than the potassium, it is very close because fluorine has a very higher electronegativity than the potassium. So, because of that, there is a partial, not partial, there is a complete charge, charge separation will be there. And the compounds of potassium fluorides get composed of K positive, that is cation. Fluoride means F negative anion. So the ionic compounds they do not form individual molecules. They compose of just two or the three atoms. Okay, and ionic compounds they're composed of literally billions of cations and anions, which are electrostatically very much attracted toward each other. And the ionic compounds in critical form are just simplest ratio of the cations and the anions. So you can see this is the crystal lattice of NaCl. So NaCl is just like Na positive and Cl, both the ions, and in between there are hundreds of billions of sodium chlorines. They are getting attracted towards itself and making ionic bond. So there are some factors that determine the structure of the ionic compounds, the crystal lattice, and first of all, the charge on the ions, size of the ions, and as what is the charge? What is the ratio of cation and anions? And what is the larger ions will not fit in the same arrangement as smaller ions will. So it is also important to know about and ions are arranged within the lattice in such a way that to maximize the separation like charge ions, minimize the separation unlike charge ions. So I will conclude here that the ionic bonds is made between the ions and it's made between one metal and another non-metal. Non-metal is highly electroactive atom and metal is electropositive atom and there is a complete separation of charges. Now come to the second point, that is the covalent bonding. So here, when two atoms have very small difference of losing or gaining the electron, you can see the tendency to attract the electron pair is very less, and you can say very little bit electronegativity difference between these two atoms. So then they just share the electrons, and covalent bonding is formed. So difference in the electronegativity can also be used to determine if the electron will be shared equally or unequally. So often instead of using single line to indicate the covalent bond, an arrow can also be drawn. So here arrow is there. This arrowhead will be only towards it is pointing towards the atom with greater attraction of the electrons. So means here fluorine is more electronegative than the hydrogen. So by using this scale, we can get to know about that covalent bonds can also be non-polar covalent bond, polar covalent bond, and as well as ionic bond. What is between this polar and non-polar covalent bond? Pure non-polar covalent bonds when electronegativity difference between the two atoms is very less. It is zero. Like, but if it is less than two, if they are coming in this range, then we will say polar covalent bond. Why we are saying polar? Because here energy difference, that electronegativity difference little bit higher rather than this. So there is a small partial charge separation will be there. But in a, like that ionic bond, there's a complete separation of charges, but here incomplete. Because of the incomplete, they are covalent bond, they are sharing the electron, but they are little bit polar in nature. So, like if I take one example, hydrogen and fluorine. So fluorine is more electronegative atom, but they are not separated like fluorine is here and hydrogen. No, there's no complete separation. They are just little bit close, but there is a partial charges there. So here, this type of bond is called polar covalent bond. Like electronegativity, that that it's the ability of any atom to attract the shear pair of electron towards itself when they are making a bond. So as larger electronegativity means an atom attract the shared pair of electrons more strongly towards itself. Okay, and like in HF, fluorine is more electronegative, so it will attract the shared pair of electron towards itself. And difference in the electronegativity between the two atoms in a bond is a measure of bond polarity. Larger the difference in the electronegativity means it is a more polar. Okay, so we can say if it is zero, the bond is covalent, and it is between 0 to 2, less than 2, then it is polar covalent. But it is greater than 2, then it is ionic bond. Here you can check the periodic table. Here this S block element, this is the P block element, G block element. So here they are saying when you are going from left to right. Okay, so left to right, what will happen? Electronegativity increases, sizes decreases, electron. But when you are going from top to bottom, then it is getting decreased as sizes increases. Okay, so uh, what are the different characteristics of the covalent bond? So first we have already done that non-metal, between the non-metal atoms or non-metal and the hydrogen atom. Non-metal atoms and no between or between the non-metal and the hydrogen atom. So electron sharing is there. So in this type of bond, what will happen? Each atom they contribute one or more electron to the shared pair of electron. There is a sharing of the like money. If somebody is going for a pizza, they are sharing the money and they are having the pizza. Both they are getting the stability. So the shared electrons they are attracted to the nucleus over the both atoms and they are just holding it. Electronegativity that we have already done with the Pauling scale. That was the Pauling scale that we have already done. I'm not going to discuss it, but you can read it by pausing this video. Stable electron configuration. Definitely, they are going to complete the rocket. Similarly, molecular orbitals. In covalent bonding, shear electron occupy molecular orbitals that extend over both the atoms. So how they happen? They are making overlapping. This is like this. Overlapping of the atomic orbital of both the atoms. The formation of molecular orbital, they are saying the delocation of electrons. The delocation of electron on the both atoms, because of that, the stability of the molecule is getting higher. Multiple bonds. Yes, in covalent bond, there can be a formation of a single bond, double bond, triple bond. Okay, by sharing the pair of electron. Like if I take one example, in O2, there will be double bond, one sigma, one type. In N2 molecule or in H2, H2 is having single bond, but in N2 we are having triple bond, 2 pi 1 6. So this only can be done in covalent bonding. So molecular compounds, they have lower melting points than ionic compounds. Molecular compounds are poor conductor of electricity in any phase, and they have a wide range of solubility in water. So they can easily dissolve in water, and sometimes they are not. Okay. So they are poor conductor of electricity, like in case of ionic compounds, you can say ions. The movement of the ions, they generate electricity, but there is no charged particles who can create the electricity or who can create the electric field. So they are non-conductors. Solubility in water. So as you know that water is a polar molecule, H, because the water is something H2O. It is like this. OH negative. Sometimes we can write like this, H3O positive plus OH negative. So this H3O positive and F both are the same. This is hydronium ion. When this H positive, the proton is in the water, so it behave like H3O positive. So in which there is a charge separation within the molecule, so that one end is partially positive and another end is partially negative. So the compound that are also polar, they can form interaction with the water molecules. They dissolve much like ionic compound. So non-polar molecules cannot form any interaction with the water. So they do not dissolve in water. Who can not make some ions or partial charge separation, they can't be dissolved in water. So this is something that general properties of ionic compound and a covalent compound. Like NaCl, Na positive, Cl negative, it's a ionic compound. CCl4 is a covalent compound. It is solid. Here it is liquid first. So because of that, you can check everything is high and it is very low. They are good, they are poor. So basically, it's all about their comparison. Ionic have strong bonding rather than the covalent bonding. So in covalent bonds, atoms still want to achieve noble gas configuration according to the octet rule. So rather than losing or gaining the electron, they share the electron. Basically, simple. Sharing of electron is called covalent bonding, and that bond is, we will say, bond pair. The electron which are getting shared. And if I'll take one example, that how these chlorine, the Cl to form a covalent bond with itself. Now you can check both the chlorine, they are first non-metal. It's also having 7 electrons. It is also having 7 electrons. It wants 1 electron. It's also wants 1 electron. So how they will share? You can check it. Each chlorine wants to get 1 electron to achieve the octet. Neither atom will give up an electron. Chlorine is highly electronegative, both the chlorine. So what to do? How they can achieve it? Simply by sharing the electron. Now you can check. This pair is on a same distance for the two atoms. Now this chlorine is having octet complete. It's also having the octet complete with 8 electrons. So although the octet is achieved by sharing the electron pair in the middle, so they are forming a one bond pair. You will say bonding pair. And this single bond can also be designated the bonding pair. And single bonds are abbreviated with the dash. Let's see it. In the case of O2, it's a diatomic molecule. Both the non-metals, electronegative atoms, they also, but they don't. It's having 6 electrons. It's having 6 electrons. So they want two electrons. So there will be electron sharing of two electrons. Now check how they are going to be. They are getting close, very close now. Two bond pairs. I will say 6 valence electrons plus 2 shared electrons, full octet on the same side. It's also working. So two bonding pairs are there. So this is making a double bond. And here, for your convenience, we have marked the double bond like with the two dashes. So metallic bond.